Okay, here's the question that group 2 was solving. So we have a triathlete who can swim 1 meter per second, and they're training by swimming across a 20-meter wide river, but she gets pushed 10 meters downstream while she's trying to cross. Okay, so a couple of things we need to think about here. So we have some different values that we are working with. And one thing that we have to understand, we did a lot of problems about free fall, but if you think about this situation, right, she's not in free fall, she's in a river. So this problem, in terms of our solution or our strategy for solving it, we have to realize that there is no free fall here. And we are going to have, therefore, we are not going to use acceleration. So there's no acceleration happening. Okay, so we're not going to use acceleration due to gravity because she's in this pool, she's not falling. All right, so assuming that she swims perpendicular to the river, how long will it take her to cross? Well, even though she's not falling, right, we don't have the dimensions of vertical and horizontal, we still do have 2 dimensions. She's moving this way, but the river is also moving her this way. So we need to define these sides, and really you can define them however you want. I'm going to call this the distance across the river. I'm going to call this the distance down the river, or let's say distance to the side. How about that? Distance to the side. And this would be the speed of the swimmer. Okay, so I'm just using the subscripts to define different things. So assuming that she swims perpendicular to the river, so perpendicular, like the river's this way, and she swims across the river, so perpendicular to the river, how long or how much time will it take her to cross? So when we're solving that question, if she's just swimming across the river, how long does it take her to cross? We just ignore that anything happens over here, and we're just going to say, how long would it take her, if she's swimming at 1 meter per second, how long would it take her to swim all the way across the river 20 meters? So when we come to our formula sheet, we are interested in a time, and if we think about what we know, right, we know the velocity of the swimmer, we know the distance across the river. Okay, and we want to know the time. So this is 20 meters, this is 1 meter per second. Okay, so I'm going to come to my formula sheet and find something that's got those 3 pieces. So I've got a velocity, I've got a distance, and I've got a time. And if we check it out, we've got this equation right here. Of course, we've got to rearrange it to solve for time, but I'm just going to go ahead and use it as is and substitute in values. So V equals distance, or change in x over time. Change in x and our distance across are those same, that's the same variable. So we've got 1 equals 20 divided by time, right? Let me make sure that looks like a 1. And so I'm going to just cross multiply and solve, or however you want to do it. So I've got 1t equals 20, or t equals 20 seconds, okay? So it takes her 20 seconds to swim all the way across the river. Okay. The second part says, how fast does the river flow? Okay, well, knowing that she's in the river for 20 seconds, right? And now we can pretend like she's not actually swimming, but she's just sitting in an inner tube on the Chattahoochee, right? And sitting in that inner tube, she starts from this position, and after 20 seconds, she is now 10 meters to the side. So now we have a distance to the side. We want to know the speed of the river. And the time that she has is 20 seconds. So we still have to share the time because she can't be in 2 places at one time. Okay. So I'm going to come back to that same equation, use the exact same one, but now I'm just going to use these values. So the velocity of the river equals her distance divided by time, or the velocity of the river equals 0.5 meters per second. Okay. The last question says, another person swims across the river, so now they're swimming across the river, but instead of getting pushed 10 meters downstream, they only got pushed 8 meters downstream. So what would that tell us about the way the swimmer's moving? Well, assuming that the river, we can't change the way the river flows, so the river still is flowing at 0.5 meters per second. If they don't get pushed as far downstream, what it would tell us is that the person must be swimming faster. If they swim faster, they are going to spend less time in the water, or they'll get across quicker. and there won't be as much time for the river to push them downstream.